making the predictions. That's what it's all about. So how do we do that? Well, let's make it its own text header. So model predictions. Okay. So let's just look at it with code. My hesitation here is that, you sort of, you don't want to focus too much on your model predictions initially because we're going to spend a lot of time learning different models and how to come up with better models. Okay, so generally speaking, you want first your best model and then you want to make predictions, but it's also good to learn how to make the predictions to begin with, right? Because that's the whole point. So model.predict. Well, the idea here is you need something that's going to match X, right? So the model is set up to have that certain number of inputs. So kind of your best way to do it is actually to use the X that you have to begin with. So for instance, we could put in what? Well, we could put in X dot head. And what that's going to do, right? What is X dot head? That's the first 5 rows. Okay. And so that should have the right setup for us. Let's see what happens. Okay. You can see we get an array. It's a NumPy array. And it predicts the, sorry, I'm just shaking my head a little bit because it predicts the median house value. And we're getting a lot of negative values, which isn't good, right? I believe this is like normal that they should all be positive. So let's look at the y.head to compare these. And you can see certainly, yeah, I think there's some kind of an issue to get these negative ones. And, anyway, but if we look at the second one, right, the second one, the prediction is 43,000 and it in fact is 801,000. So that's also not a good prediction. So where are these, good values that it was predicting? Not clearly in the head. So let's try something else. Let's try the tail. Let's try the last 5 rows and see what we get. Okay, now we're getting more sensible data. And, you may wonder, well, why? There might be some problematic rows at the top. Well, let's compare the final 5 and see how we're doing. Well, if we look at the first one, the prediction was 162,000 and it's 111,000. Decent, right? I mean, it's solid. It's in the ballpark. Second one, 152, 790. Did I look at the first one wrong? No, this one's 79,000. Sorry, looking at the second one wrong. Next, we've got 95,000 versus 103,000. That one's very close. That's actually a really good prediction, right? And then we've got 58,000 to the second to last one compared to 85,000, not bad. And then 183,000 to 94,000. So, these predictions are kind of more meaningful. Now, it's still not like it's kind of weird because what we're really doing is we're just comparing, we're looking sort of really inside the model here, right? These aren't like actual predictions. Well, let's do some actual predictions. And I'm going to show you how I sort of set these up because you have to kind of know your data to make it make sense. So I like to look at it first. So X dot, maybe let's take some of these bottom rows. Let's just even look at the last one maybe. Okay. I think if you just put in 1, it just shows the last one. Okay, so, and what I'm going to do now is I'm going to make something to predict. I'm going to call this new rows. Okay. Could be singular, more than one or not. And what I'm going to do is I'm just going to start putting in this, I'm going to copy basically these values. Okay. So, I'm actually going to copy this as is and put it in here and separate it out. Okay, using commas. And what the idea here was what you do is you get some real values in, and now you start to change them because you have something that it's just a nice sort of starting place. And the other thing that can be really helpful about it, is that the last one? Yeah. The other thing that can be really helpful about it is you can sort of see how the prediction changes if you tweak it. Okay. Like for instance, let's say everything's the same, but the median income goes up. Now, this data set uses weird values. Like, I don't know like what this would mean, but we could just sort of change it to 4 and see what happens. Okay, to get this to work right, and maybe I'll just call it singular because we're just doing one, but I want to do more than one also. You would have like a bunch of different rows, and so you actually want to make this a list of lists. You want 2, this is important, you want 2, it's like it's like your entry is 1 unit long, it's 1 list, but you could have multiple lists. Okay, so that's how you get a single row. And now we can just do model.predict the new data, which in this case is just this new row. So let's see if it works. Gives us a warning, don't worry about it. And you can see it definitely, I think, went up. It went up to 223,000 from the last one, 94,000. So, you know, changing that last column really kicked it up a lot. And this is sort of how you can have fun with, you know, your predictions initially. You can put really anything in there that makes sense. I can tell you what I think it doesn't like is that we don't have the column headers. Yeah, see feature names, but who wants to take the time to do that? I mean, you could. The proper way of doing this anyways is to convert it all into NumPy arrays, and you don't use the actual names, but it's helpful to sort of have it at the beginning, to have these names. And so that's sort of the gist of it. Like, you know, you could like, let me just show you also, right, to do more rows, we'll just put a comma and do it again, right? So I can just totally, yeah, I think it might be easier here just to put it in. Let me copy it twice and then get rid of all the extra stuff, right? So a little tedious here to begin with, but it will sort of get you the right stuff. You may have some extra stuff at the end. No, it's okay. Okay, so basically that does it now. Now we have 2 rows now, but they're the exact same. And, you know, I think you all can make your own changes here, right? You sort of have to have, it has to be meaningful, right? Like, I don't know what these are just by looking at them. But the point is, like, in the real world, right, you would actually have a bunch of new data, right, of what you're trying to predict. In this case, it's just kind of fun. Like, if we tweak some of these, like, maybe we want to tweak, trying to think of something that might be fun. I don't know. Let's just, the number of households or the I don't know. It's hard to kind of pick something. Whatever, let's just go with housing median age and total rooms. Well, okay, what if it's newer, right? What if we just make that one change? If it's newer, like what kind of a change are we going to get? And so now when we'll call this new rows, plural, and now if we do model.predict new rows, you know, you can see it's showing the value. This is interesting in this case, right? Maybe the one was too new. It actually dropped. That's a little surprising, but, you know, like, it's interesting. So what if we increase it? And then we run it again. As you can see, this can be kind of fun, right? Like, because you're learning more about what your model is actually doing. And so predicting is not just sort of the main event, which it actually is at the end, and we'll get more into that later. It's also a way that you can kind of like play around with your model and see what it does when you make sort of the appropriate changes. Now, let's highlight how these predictions are made, okay? I think this is important that you understand this. So what I want to do is go back up to our graph from the very beginning and right here. So here the model is a straight line, okay? So if we have a new income and it's like 9, say, okay, what's the predicted output? You just hit the line. That's it. It's like whatever, I'm not sure exactly, 43,000 perhaps. Okay, you go straight up to what the line hits. And so when we do linear regression in higher dimensions, you have this hyperplane. And what you do is you take all the different inputs, right? It's all set. There's a hyperplane there, and you go up and you hit the hyperplane, you just read off the value. So like after you've built the model, you have sort of the hyperplane. it's in higher dimensions, but it's there, and you just go straight to that hyperplane. So after the model has been built, right, you're not doing machine learning like at this point. At this point, you're simply using your model, okay? And so a lot of the machine learning work that's done is kind of the before and after. You can see that for us, if we go back, when did the machine learning happen? You can sort of answer that question in a couple of ways. You could say, well, it happens in these sort of 4 lines of data. And you could also argue that it happens simply in this 1 line of data, because that's where the back propagation, and which uses gradient descent to update the weights, that's where this back and forth, what are the best weights until you get this convergence, where it essentially happens, right? And I think this is what you find in reality is that there's a lot of preparatory work that goes into machine learning and a lot of post work that goes into machine learning, because most of the models in the world today, right, they're not stagnant. It's not like Netflix makes their, recommendations and then they retire and all the machine learning people, are out of jobs or go on vacation for a year. They continue to sort of look at the new data to improve their models. And that's the beginning. So that is an introduction to linear regression. Hope you enjoyed it.